All right, I think I'm going to go ahead and get started here. So, hello everyone, welcome. My name is Abby. I'm the undergraduate recruitment specialist for the Faculty of Engineering here at the University of Waterloo. And I'm excited tonight to be sharing some engineering student stories. So, I won't be doing most of the talking. I have some great students here on the call who will be sharing their stories with you, all kind of centered around that topic of materials, medicine, and innovation. So, before we get into I can change the slide. There we go. Before we get into the reason that we're all here today, I do want to do a territorial acknowledgement. So, the University of Waterloo acknowledges that much of our work takes place on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. Our main campus is situated on the Haldeman Tract, and that's land granted to the Six Nations. It includes 6 miles on each side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and that is coordinated within the Office of Indigenous Relations. So I encourage you, I recognize we're all probably joining from all over the world, all over Canada, so we might be occupying different lands today. So I encourage you to learn more about the land that you occupy and what you can do toward reconciliation as well. All right, so throughout tonight's webinar, closed captioning is available by clicking the CC button that hopefully you see at the bottom of your screen, depending on what device you might be joining from. It could be at the top as well. You can also submit any questions you have throughout the webinar using the Q&A button that is also at that toolbar at the bottom of your screen. We're going to respond to those questions through typed responses, and then there's also going to be a moderated Q&A portion kind of in the second half of the event, so we might save some to respond during that session as well. If there's any questions that we're not able to get to tonight, though, or if you have any specific questions, feel free to email engine4uwaterloo.ca and our team will be happy to respond to you there. All right, so like I said, I have some really great students on the call tonight who are here to share their experiences in our engineering programs. So we're just going to kind of go through and they're going to share a little bit about their programs, what they're all about, their experiences in them, and things like that. And then in the second half of the session, there'll be an opportunity for some questions and answers. So feel free as they're talking to think about some questions, put them in the Q&A, and we can respond to those in the second half. So without further ado, I think we're going to get started here with Carice to share a little bit about mechanical engineering.
Hello. So I'm Carice. I'm currently in my second year of mechanical engineering. Abby, if you want to go, cool. So if you don't know what mechanical engineering is, it's pretty much the study of how things move and how forces make them work. So in your course curriculum, you'll be doing a lot of physics, mathematics, and material science to pretty much better improve or create machines and systems. Some of the skills you will learn in your first year are skills such as rapid prototyping, so laser cutting and 3D printing, as well as a lot of machining and shop tools and 3D modeling in CAD. As well, you'll also do a little bit of programming and learn how to do finite element analysis simulations. During your first year curriculum, some of the things you'll also do include 2 design projects, a lot of labs and lab reports, as well as in your course, it'll be enhanced through doing practice problems, assignments, and quizzes. Mechanical engineering, being a pretty broad program, allows you to enter many different industries. So some of them include aerospace, automotive, nuclear and energy, manufacturing, material science, robotics and automation, and even healthcare. I chose mechanical engineering because not only does it have a wide range of industry jobs to choose from, but growing up, I really enjoyed building and doing DIYs and taking things apart to learn how they worked. And from being from Waterloo, I was able to attend the symposiums, which is where the 4th year capstone projects are showcased. And I always found the mechanical engineering ones to be the coolest. So that's why I chose mechanical engineering. But some other programs I also considered when applying were Mechatronics Engineering, and Civil Engineering. Now being halfway through my degree, some of my favorite courses are all of the calculus ones. I really like math, and then mechanics of the formable solids. At university, a lot of professors want to see you succeed and know how tricky the program is, so they're happy to help you if you reach out. Also, professors have a lot of research opportunities that can enhance your experience at university. Some cool projects I've done so far have been the first 2 year design projects, as you see in the pictures on the side. One of them being the real life Brick Breaker game, if you ever played that on your phone. And then the other one is the autonomous Connect 4 robot. Some of the different co-ops I've worked at, I've had a few now, include working in the heavy lifting industry. I got to go to Bruce Power Plant and see one of the lifts that were being done, which was really exciting, as well as I'm also interested in the nuclear energy sector. So being able to go there was a pretty fun experience. And then I've also done a lot of design focused positions, doing CAD models and quality testing them. In my spare time, I like to stay active. So I've joined some different sports. So I've done intramurals for ice hockey and ultimate frisbee, as well as I've joined the underwater hockey club, and I like to crochet in my spare time. For school-related extracurriculars, I've joined some design teams to enhance what I've learned in school, and some of them include University of Waterloo Steel Bridge team, as well as Watt Turbine. My final takeaway about mechanical engineering is if you like being more hands-on and really enjoy math and physics and want to do more application-based activities and kind of actually see the physical thing you are making, then mechanical engineering is definitely for you. My advice to you, if you are interested in mechanical engineering or aren't sure yet, there are so many opportunities for you to explore and lots of ways to enhance what you've learned in class to real-world situations. I'll say a lot of learning happens on the job, which is why our co-op program is also really amazing for that. And now I'll pass it off to Mule, who will talk more about mechatronics engineering.
Hey everyone, thanks Therese. I'm Mule. I'm a fourth year engineering student studying mechatronics, and I'll talk a little bit about what that means. So the name Mechatronics Engineering seems weird, but it's a combination of mechanical and electronics. And most of our curriculum would be hardware based. So you would learn main skills like 3D modeling, which is like CAD design. These relate with your mechanical design jobs. We'd also do some electrical circuits. That's where the electronics parts comes in. This relates with your electrical design jobs. And we also take a couple of programming courses here and there throughout our degree. And so this relates with software jobs, which I myself am like have done throughout my co-ops. For courses specifically, your first and second year courses are more theory based. So you would have your lab, or sorry, your tutorials and your lectures. And then when you get, more experience and you have that theory behind you, you can now do more project based. The photo on the right is a robot that I built in third year. This was like a group project where we come problems defined, you build a platform to balance a ping pong ball and then to move it in certain trajectories. But sounds simple. You have to do everything from design, picking parts, building the thing, testing the thing, and then making sure it works at your final demo date. So yeah, all that is later in your third and fourth years where you have more project-based courses. Personally, I chose mechatronics because I did FRC in high school. I liked it. Friends that graduated ended up studying mechatronics at Waterloo, and they said great things. So word of mouth and also, personal interest. Those were the, I guess, main reasons for studying mechatronics. And then I also did my research. I spoke to current students via EnchChat. Great resource to get perspective if you personally can't come to Waterloo, or coming to our fall open house or our March open house. That's also a great way of talking with current students. And the one thing that I've learned now after being in the degree for like 4 years now is Tron is really for those that like a little bit of everything. Like you like the mechanical, electrical, and software components combined together, but you still also want to take time to explore before picking one to specialize in if you choose to do so. So yeah, my experience overall, some of my favorite courses right now are autonomous robots and intro to machine learning. There's like a variety of courses that you can take. I'm currently taking the systems design version. These are technical electives, which you will take in fourth year across your 2 terms. These make your degree, help you like specialize your degree because you can pick either a combination of mechanical, electrical, or software electives, or you can hone in on one of those particular areas. In terms of co-op experience, I've done one research term in biofuels with a professor. That was cool. And for most of my co-op terms, I've done software engineering. I did 3 in Vancouver and 2 in Seattle. The photo on the right is from one of my favorite hikes in Seattle, North Cascades National Park. It's, the co-op is a great opportunity to explore other cities and also different types of jobs. So definitely take advantage of that. In terms of extracurriculars, I run a peer mentorship club specifically for mechatronics students. This way, incoming students and also younger year students can ask upper year students for advice. Entrepreneurship scene in Waterloo is also very vibrant. We have a bunch of incubators, which include Velocity and Greenhouse Social Incubators. This is for those that have some idea for a venture and they want to get some help in terms of taking their ideas in their head and putting it on paper and then validating that against real world markets by talking with people and also building things. And my involvement in these entrepreneurship activities helped me scope out my current capstone project, which we're building an automated farm to grow high protein plants. But yeah, overall, I would say if you're interested in mechatronics, make sure to take a look at the course schedules for Tron and ask yourself if you like every aspect from mechanical, electrical, and software. You really don't want to be in a situation where you only like one of them because we have other programs that might suit your, academic needs better because you can change anything about the degree from where you work in co-op to what clubs and extracurriculars you do, but you can't really change the courses you take until like 4th year when you can take your technical electives. So make sure you like at least most of the courses that you'll be taking. And also, I see a lot of students asking about well, what if I don't have FRC or VEX robotics experience because, my high school doesn't have that. Don't worry, you don't need to have it at your school, to apply for Tron. Just make sure that you yourself know why you are getting yourself into this space in terms of, oh, maybe I did some side project or maybe I took a course that exposed me to this. And that's what, is motivates me to take Tron basically. And lastly, if you're on campus and you make it into Tron, definitely go to campus events, especially if they have free food. But yeah, I'll hand it over to Amelia now.
Thank you, Mule. My name is Amelia. I'm in 3B of Biomedical Engineering at Waterloo. So why biomedical engineering? To begin, biomedical engineering is solving real-world technical problems in the medical field. So it's taking your engineering skills that you have, like your physics, your math, your calculus, and you're applying that to the medical field. Skills can be technical, skills can be design. So technical skills you'll learn will include like programming, physics, and biology. Design skills can include prototyping, 3D modeling, and simulations. My day-to-day homework is evolved around design projects, practice problems, and lab reports. From biomedical engineering, you can really branch off into different fields. So you can go down like the healthcare services path. You can focus on medical devices. You can focus on medical imaging, biomechanics, or medical AI. So it's a very wide scope that you can go into. So why I chose biomedical engineering, I personally love playing sports, and my favorite subject in high school was physics. So learning about the physics of movement and sports and activity was really interesting and cool to me. From being in this program, I've learned that it's very diverse and covers a wide range of technical skills. I did apply to biomedical engineering, but I also considered mechanical engineering as my second option, but I loved staying within the medical field. So my experience so far, my favorite course, 2 courses so far have been mechanics of deformable solids. So that's like our basic physics class, learning about forces and things like that, and our anatomy lab. So this was like a hands-on lab, and we were working with cadavers, which might sound a little intimidating, but it was really cool to see how the human body works and everything like in real life. Professors in biomedical engineering are very supportive. They all want to see you succeed. They want to help out. They love to help if you reach out to them. A cool project I did in my second year was my partner and I built a 3D system that helped form amputees play basketball. This was just a lot of circuits, a lot of 3D design, a lot of working together to come with this. This was a semester-long project. In one of my previous co-ops, I worked with Harvard Medical School and the Massachusetts General Hospital to test a medical imaging device. So this was imaging within the ear. We worked with like the postdoc students, and we were able to do like clinical trials of the device in the hospital. And while I'm on campus, I love playing intramural sports and dropping in at rock climbing sessions. So some takeaways and final thoughts. There's a lot of problems in the medical field that need people to attack them. And they are a very wide range of problems. So you could be automating disease diagnosis to developing in vitro novel devices. There's not one solution that will fit all these problems. Students will be provided with all necessary skills and choose their own path. So like I said at the beginning, biomedical engineering is very wide where you can go into. I think biomedical engineering is a great option for students who enjoy physics and problem solving and want to apply that to the healthcare field. So I'll pass it off to Megan.
Hi, I'm a 3B chemical engineering student. So chemical engineering kind of uses all your three different sciences, your chemistry, your physics, and your biology, and combining that with math to be able to design processes that convert raw materials into useful products. So chemical engineering touches a wide range of industries. Some of the major topics you'll see throughout your 5-year degree include your reaction engineering, thermodynamics, fluid mechanics, heat and mass transfer, process control, simulations, and lab techniques. A lot of these courses you'll see more into your upper years, into your second, third, fourth year. Your first year and a half in your degree, you'll focus a lot on building your fundamentals. So when you hit the later point, you'll be able to have a solid foundation to really kind of grasp and move into the designing and understanding large scale processes. Chemical engineering touches in many different industries, not just limited, but including energy, pharmaceuticals, food processing, environmental technology, pulp and paper, and materials and polymers. I chose chemical engineering based on the industries that I was interested in when I was applying. I had a huge interest in batteries and in environmental technology, and it was something that I wanted to explore more of through my degree and through my co-op experiences. I've continued to learn that chemical engineering requires the understanding of chemistry, but that's only a small part of what the program is as a whole. You have a much bigger focus on designing and optimizing processes. So far, through my degree, my two favorite courses have been Mathematics of Heat and Mass Transfer, which is a third-year course, and Strategies for Process Improvement and Product Development, which is a second-year course. And that course focuses a lot on dealing with data sets and working on optimization and being able to use the data to figure out what you're kind of trying to gain from the data. Um, Chemical engineering has fewer projects than a lot of the other engineering streams. You'll see a lot of projects in first year, including the big soap design project. That's where you get to go from the beginning stages of figuring out what you want your soap, what properties you want your soap to have, and doing all the calculations that go with that into making the soap in the lab. And then you do a symposium at the end that where you're selling it to others and convincing them that you made the best soap. On the right there, you can see that there are some pictures from my first year soap symposium, and there's two different soaps there that were made. So far, I've had different co-op experiences. I've been able to experience multiple different industries. I've worked in pulp and paper, I've worked in automotive, and I've worked in aluminum extrusion. In each of those co-op experiences, even though the industries are so different, every skill that you build in one carries over and becomes an asset into your next co-op. And that's something that I've continued to learn. Outside of just academics, I'm part of the Chemical Engineering Student Society, which I will say is one of the bigger department-focused student societies. Right now, we've been running weekly events, everything from trivia to movie nights to the big chemical engineering tradition of the coffee house, which will be next week. In terms of the department and our professors, there's a lot of support that's provided. The department is always looking to take the feedback from current students and to make changes to make the program better and stronger for the next year's set of students. My final thoughts would be chemical engineering is very broad, just like many of the other engineering streams. And as I said, the skills you build through school and through your co-ops will continue to carry with you and will become an asset as you continue through your degree. I found that co-ops made a huge difference in understanding what industries and what types of work I enjoy. I've been able to experience doing R&D and different sides of manufacturing, and it helps me weed out what I'm not looking for into the future and kind of what I want to do with my next co-op. The last thing I'll say is don't pick chemical engineering just because you like chemistry. Chemistry is one part of what we do, but there is still a lot of math and physics and a big focus on problem solving. I'll now pass it over to Caitlin to talk about nano.
Hi everyone, my name is Caitlin and I am a 2A nanotechnology engineering student. So one of the biggest questions we get is what is nanotechnology? I think the best and how do we incorporate engineering into that? And I think the best answer to that um, is that you can create different solutions across different industries from a different perspective, because everything that we work with is now governed by quantum and physics instead. So we work with different properties and utilize materials in different ways, and then use that to solve problems across a variety of different fields. So through the program, you learn knowledge in chemistry, materials, electronics, biology, and of course, quantum mechanics, because that is what is governing, that's what makes nanotechnology different from just your regular materials. And then we learn all this through a lot of labs. It's a very lab heavy program, whether you're synthesizing new materials, and then characterizing them with really specialized equipment like SEMs, or you're making these little teeny little devices in a clean room. And you learn about that right from first year, as well. You learn about all the different equipment that you can use. There's bio labs where if you think about like vaccines and mRNA vaccines, those were created using nanotechnology. You also like the diagnostic side of that with PCR testing. You get to learn about that. And then as well as electronics, you go all the way to like batteries and capacitors and how do we design that and make those more efficient and better. So like I said, we touch a lot of different industries, really where you can apply a unique material or application of nano, you can find an industry for it. So we have electronics, it's a big push towards electric vehicles and things like that. Well, nanotechnology is helping making those batteries more efficient, so we can use them more. There's also medicine, like targeted drug delivery, things like that, manipulating particles so that we can really target where in the body that they're actually going, as well as materials engineering and additive manufacturing. How can we make your cell phone lighter or your running shoes faster? You're really utilizing knowledge of material science. You have environment, as well as energy and even aerospace. A girl in my class is working on satellites for her co-op, and how can we make those and improve those better utilizing nano? So what really drew me to this program was the applications of it and how unique they were and how you could attack problems from really a different angle utilizing nano. One of the ones I was most interested in was I heard about they were doing targeted cancer treatments. So it was like targeted so you're only really reaching those healthy cells instead of all of the sorry all the cancer cells instead of all your healthy cells, which is a really big problem with cancer treatments now. Um, and then also for environment, I'm from a mining town. There's a lot of tailing ponds, and they're using these nanomaterials to really extract like the toxic metals out of those ponds and make. So there's a lot of different applications, and that was really what interested me. So some of my favorite courses from first year were linear circuits and nanomaterial health risk. I wasn't really expecting to like electronics, but since you take basically every foundational course, you get to figure out what you do and do not enjoy. So I ended up really enjoying this class. And then because I was really interested in the bio side, I really liked to see how materials change and how they affected your body when you put them at a different scale. So the health risk class was also really cool. And then I think one of my favorite things about this program is the professors and the community, even just within your own class. Professors, you can tell that they really love like teaching and talking about nanotechnology and the impact that we can have using it. And they're interested, they really want to see you succeed just beyond their class. And it's really, really evident in the community of our program. So something on the side that I'm working on for a project is through a design team. We're working on conductive inks for flexible electronics, which we use for sensors and things like that. But we're really focusing on the silver nanoparticles, which are really conductive at that nanoscale, but not something maybe you see a lot of at a bulk scale material. Um, so I've only had one co-op, and it was actually on campus working in a research lab, and I think it was really cool to see some of the stuff we learned transferred into the lab and also learn a lot. It was a huge step for sure, but I worked in with bio nano devices with microneedles, and we integrated nanomaterials into that to do drug delivery for things like skin cancer or fighting like bacterial infections. And I really, really enjoyed that lab experience. Um, I look forward to doing more co-ops like that again. And then outside of school, I'm also on the varsity cross country running team, and I also co-lead the chemistry team for the nanorobotics design team. So some final thoughts. I'd say nanotechnology is a very multidisciplinary program, but it can open to doors in like like a wide variety of different fields. So you can really cater your interests to wherever you want to kind of apply those skills. And through the co-op program, you have the ability to figure out which industry you fit in and how you can apply those solutions to that industry. And you can really explore so many different industries that way. And then finally, I'd say coming into this program, be really open to learning like a variety of new material. I think that's a strength we take away is that we adapt and we're able to learn things very quickly because we have to learn so much foundational knowledge to even get to learning like the quantum physics that governs everything we do. Enjoy also like hands-on learning. A lot of our program is taught through labs and projects, especially as you go into upper years. So really um, enjoying just being there and synthesizing your materials. Um, as you can't see it in the same way as a mechanical engineer could. We have some really cool microscopes that let you see it too.
All right, thank you so much. Before we move into our moderated Q&A, I just want to highlight a few ways that you can continue to ask questions and learn more after this webinar. So we have something called Engineering Shadow Days, where you can come to campus and shadow a current student, kind of experience a day in the life, and that sort of thing. So definitely encourage you checking out that. We are kind of heading towards the end of the term at the moment. Classes are going to be ending soon. So you might be looking at the new year for those shadow days, but definitely encourage you to check those out whenever you might be near campus. Admissions questions can always be emailed to enginefo@uwaterloo.ca. We're happy to answer those anytime. And if you just generally have a question and you're not sure who to direct it to, Enginefo is a really great place to go. And if we're not the right folks, then we'll forward it to the right people. And the last one I wanted to highlight was our Ask a Warrior, or Mule mentioned it earlier. Eng Chats is another term that we call it. That's where you can chat virtually with our student ambassadors. So all of the students who are on the call tonight are student ambassadors, and they're available to chat virtually with you on that platform. So I really encourage you to continue the conversation both with them and other students on our Ask a Warrior platform. So with that, I'm going to stop sharing my screen and we can have all the panelists turn their cameras on, and we'll move into our moderated Q&A. So if you do have any questions for any of our panelists, feel free to put them in the Q&A now. I just want to get started, I guess, with some specific questions that have come in, and then we'll kind of move to some broader questions. But question for Megan, specifically for chemical engineering. How much of chemical engineering relates to pharmaceutical, if that's something that students are interested in? This person in particular was saying that like they feel like a lot of things that they've seen are related to polymers in the environment. So do you want to share a little bit about where pharmaceuticals are?
Yeah, so we don't have as many courses that'll touch on pharmaceuticals. We take some of our bioprocess engineering courses in your upper years, but that definitely be something you can explore and see more of in your co-ops. I know I've seen companies like P&G that'll touch into pharmaceuticals on our job boards, um, but not our courses specifically don't touch as much on that. We go a little bit into bio. And with your electives, you can go a little bit more into the biological route, but our general courses don't touch as much into pharmaceuticals.
I appreciate that. And while I have you, we'll continue on. And I kind of want to ask all the panelists this question as well. But the question is specifically, is chemical engineering the most lab heavy out of all of the programs? I don't think we have exact like stats on how many labs are in each program, but if you'd like to share a little bit about your lab experience in chemical engineering, and then maybe we'll hear from the rest of the panelists about their programs.
Yeah, so I think chemical engineering does their labs a little bit different than the other programs. So what they've done is it's all of our labs are essentially consolidated and kind of organized. So you take one lab course for almost each of your school terms, and you'll cover different topics from previous courses you've taken. So then you're touching a lot more on all the different subjects without having a lab course attached to every single class that you're taking. So it does make it a little bit easier and allows you to, I guess, experience more topics and more of the different labs that we get to do.
And sorry, just to as a follow-up to that, what do your labs look like? Like what sort of activities do you typically do?
So I'd say when your first few lab courses, you deal with a lot more of the hands-on things, dealing with different reactions. You even touch on some of the different biology more so connected labs. We do a battery lab where you get to make like coin cell batteries. We do distillation labs. Just about every topic you will cover in your courses, you'll probably see it in a lab at some point. That's what I've learned. Just gonna touch on something else and it just slipped my mind.
No worries. If it comes back, let us know. Caitlin, I know you mentioned when you were talking about nano that it's a very lab-heavy program. What do your labs look like and how often do they occur?
I think especially once you after 2A, like a lot of your courses are labs, but like I had four different labs this semester, and it is like a very, very lab heavy program. We do most of our learning through labs. But they all look a little bit different because we have like our electronics labs and we also make batteries, like chem eng, but we also do capacitors and just basic circuit stuff. You have your integrated circuits, those are all done through labs. And then you also have your bio labs where you're introduced to like PCR and cell cultures and different things like that. And then you have your materials labs where you can synthesize polymers and characterize them and then test them and mechanically and microscopes. Um, You also have the whole clean room lab, which is a whole facility of itself, designing different devices and things like that. And I was speaking to some of our professors recently, and they mentioned that we actually do have some of the most heavy lab hours of all the engineering programs. There's so many that you can't take them all. So there's so many different labs you can take with Nano, and you can really cater that to your interests as well.
Absolutely, yeah. And I know Nano has a lot of specialized labs as well that only Nano students have access to and utilize. So if I
Sure.
had to wager money, I think it would be towards Nano as far as the lab heaviness.
Yes, for sure.
Yeah, sorry,
Hmm.
I forgot to touch on just the kind of the second half of your degree with those labs. So I mentioned kind of your first 2 years you deal with a lot more hands-on labs. Once you get into upper years, you have more you're looking at more processes, so you're dealing with a lot more equipment and machinery. For example, we do like a plastic extrusion lab. So you're not like your hands aren't going to be on like physically doing any of the extrusion. It'll all go through the machine and you're dealing with all the parameters and setting the parameters and seeing the differences more so than doing it yourself.
Okay. Yeah, it kind of sounds like it almost gets like larger scale as you get into your upper years. Yeah. All right. Amelia, I would love to hear about biomedical engineering labs and then kind of a two-parter question. How much bio is in biomedical engineering? Is there a lot of biology or is it more about the tech and physics?
Yeah, so labs first. Again, labs look so different depending on the course. I would say in biomedical engineering, our labs are addition to our courses. So when you have a class, you will, for your like, let's say harder classes, you'll have a lab to help you learn. So like in your beginning of your degree, you'll have like a biology class and you'll have a biology lab. And then you'll have like a physics class and you'll have a physics lab. So right now I have like a controls class, which is like a math kind of class, and I have a controls lab. So they usually go hand in hand. As you're learning the content, you're also having a lab to like practice the content, which is nice because what you learned in lab kind of helps you study for the class that you'll have like an exam and things in. Um, yeah, labs look super different. We have like circuits and electronics labs. We'll have like our biology or like chemistry labs. We have a lot of design labs, like a lot of like 3D printing and like workshop type of labs. So yeah, super broad and depends on the course. Is biomed heavy in bio? So it's always like a tough question because it depends on where you choose to take your degree. Personally, I'm going down the more biomechanics, which is a lot more of a physics route in biomedical engineering, but there is the opportunity to go in a heavy bio route. We have like a tissue or like a neuro engineering specialization. So if you want to get super biology focused and like cells and things like that and tissues focused, you definitely can. But if you don't want to, you don't have to. You do have to have a general understanding of biology. We will have like a physiology class and like your cell biology class, just so that you know the systems that you're working with. But if you don't want to specifically work with those systems, you don't have to. So it depends. It depends on your choice of the path. Yeah.
Hmm. Yeah, good to know. And I'll say too, for the other programs, specializations are just generally, I think, a good way in your upper years to specialize in a given area. Mechatronics does not have any specializations, unfortunately. Mechanical has just one, the welding and joining specialization. Otherwise, chemical, nanotechnology, and biomedical all have several specializations, so definitely worthwhile to look into those on our website because those can be great ways to kind of specialize within broader programs. And then for those programs that don't have many specializations, there are something called options as well that you can look into on our website. That's available for all Faculty of Engineering students. Carice, you talked about with mechanical engineering that it was very like you can see what you're doing. What does that mean in terms of labs?
In terms of labs, in first year we have two design projects, which is nice. They're like the hands-on aspects where you get to build stuff and think like an engineer kind of. I think we have the most design projects in first year compared to the other programs, but I'm not super sure, but I believe we have that. Besides that though, in second year and upper years, we only really have like currently I'm in 2B, so we've only really done like electrical labs. So learning how to do like connect breadboards and high voltage stuff and stuff like that. In upper years, though, there are, if you go into these paths, I believe there's like fluid mechanic labs and like things like that you can do. But those are also research-based areas. So if you decide to do like research with a professor, you can do more of those. But yeah, as of now, so far, the only labs we've had are really electrical based and then the design projects.
Thank you. And last but not least, Mule, what do your labs look like?
I think the labs have changed throughout the years. Like earlier on, it was like you go into a materials lab and then you get to play with like breaking things and seeing how, like, for example, if you go take some steel and then you put in some contraption and you stretch it, at some point it'll break. And then we kind of like figure out how much force it took to break that material. So like more like simpler labs, and then now in fourth year we have a lot more like you have to do a lot of pre-lab work. Basically, for my autonomous robots course, you have to write your algorithm before you go in lab because you won't have enough time to do everything in lab. And then lab time is specifically you run your code on the robots and then see how they function. So younger years, you do more work in the lab and then, you write your report afterwards. In terms of scale and scope and difficulty, it's a lot less. Upper years, I mean, depending on the courses you take, the labs are more involved and take more time, and you have to do more prep outside of class for it.
Yeah, that's helpful. That lab does sound very cool though with the robots. So it's kind of that trade-off, like it gets a little more intense as far as the work that you're doing, but maybe the topics become more interesting.
Yes.
Mhm. All right, diving back to our questions. So let's circle back to Amelia, and then maybe I'll see if anyone else has thoughts on this. But what are some of the hardest classes slash concepts in biomedical engineering?
Again, this is like so dependent on the person because different people are going to struggle with different concepts. I would say the general consensus for my class was in the younger years, like in first, you have three calculuses, and I would say because they're always growing on top of each other, if you're blurry on a concept in the first calculus, it makes the upper calculuses a little more difficult. So I'd say the consensus is calculus can be a little tricky in the first few years. Some of our physics classes also get a little heavy, like our dynamics class or like our fluid mechanics class. I know some people have struggled with those, and then labs can be a little tricky. Like Moulay said, there might be a lot of pre-lab work, and that will just get like very heavy. I wouldn't say that it's super difficult, it just is like super heavy.
And kind of a follow-up to that related question, how much of a jump would you say was it from high school to first year, if you remember first year? And what advice would you have, I guess, for prospective students who are concerned about that?
Yeah, I mean, a big jump is just a change in life. Like I'm cooking for myself, I'm doing my own laundry, and I'm telling myself when to do homework. It's not somebody yelling at me to do it. So I'd say in general, it is just like a switch, but it's like it's a really cool switch. It's a really fun switch. You're meeting a lot of new people, getting involved in new clubs, and I don't know. It can be stressful and overwhelming, but at the same time, you're having like the most fun you've ever had. So it's just a balance of it all.
Absolutely, yeah. Does anyone else have thoughts on that question of like concepts that are difficult in your programs, that leap from high school to university? Anything around that? It's okay if you don't.
Yeah, I can touch on that as well.
Mhm.
I'd say that transition from high school to university, um, I would agree with Amelia. It's a lot of it is just the like there's so many different things that are changing. I will say the workload is more than high school, especially just you're you always have multiple things going on. There's always multiple things that you have to do. But the content, especially think the content you see before your first midterms, a lot of that would have been covered in high school. For us, chemistry, calculus, kind of drawing a blank on the other ones. I know those ones you will see like a lot of that content you've already seen. I think the big one that's completely brand new for chemical engineering is linear algebra. And that's why a lot of people will say that's one of the hardest courses you'll see in first year or in 1A. Um, Besides that, I'd say course concepts like the most challenging. I know right now for us, it would be in third year is process control, just because the level of math and the application of it can be very difficult to wrap your head around. Something that's even brand new for us now. We've seen some of the math, but I know a big part of that too with what different people struggle with is different professors will have different teaching styles. And so it could be difficult for you to pick up concepts in one class just because of how the professor teaches. And then that kind of will carry with you until the next course until you can manage to catch up with it.
Absolutely. Thank you. Any other thoughts on this topic before we move along? Okay, lovely. One more, unless folks want to, I mean, continue putting your questions in, but one more at the moment for biomedical engineering, a specific question is whether, so biomedical engineering is one of those programs where it's like a blend of different kind of disciplines in engineering. So this person is wondering whether it leans towards a certain type of engineering.
Uh, I wouldn't say it leans towards. Personally, I'm kind of doing like the mechanics within biomedical, and like my friends doing like AI within biomedical. So it doesn't lean you specifically into one of the paths.
Yeah, and I think like you were saying before too with the specializations, like everyone kind of takes those fundamental courses and then in your upper years you can really decide specifically what within biomedical engineering you want to focus in on, if anything, or you keep it broad. So yeah, a lot of options there. I'd love to dig a little more into co-op experiences because that's a really, I mean, it's a big highlight of your degrees as engineering students. So Mule, you've had the most co-op experiences of everyone on the panel. Do you want to share maybe your favorite one, if you have a favorite, the one that's kind of stood out the most, and what you did there?
Sure, I can make it quick. Last one I did was 8 months in Seattle. I worked at Amazon doing software engineering. It very basic web development work, like working on websites. Particularly, I was under the pricing department. So, like, if for Black Friday or Cyber Monday, like all the deals, we would be the ones to validate whether or not this is a good price for customers or a bad price. Because, like, we don't want people to get bad prices and then not shop on Amazon. Yeah, so it was cool because I was able to deploy something to production. So like stuff that people actually use. Usually interns don't do that, but because I was there for like 8 months, they were like, yeah, we can take a chance on this guy. He seems to know what he's doing. And then yeah, like work wise, it was good. Like big tech companies, it depends on the team. Like like some people they go to a company, they don't like it. Usually it's because the team either overworks them or this and that. But my team at Amazon, it was good. People left the office at like 3, so like no overwork. And then Seattle was also very beautiful. If you love hikes, I went on like 4 to 6 hikes, and 3 of them were at national parks. So co-op is a great opportunity to just get out there and hang out with interns, but also explore nature if there's nothing much to do in the city. I mean, Seattle, there was stuff to do, but it's just the hikes there were great. So recommend that if anyone in the future goes to Seattle.
Absolutely. I feel the same way. When I was a co-op student, I saw the mountains for the first time in like Calgary and stuff. I'd never seen it before, so great opportunity. Um, Follow-up question for you. Is there a lot of programming in mechatronics engineering?
I would say not as much as electrical and mechanical courses. We have like at most 4 programming courses. 2 of them you would take in your first year, and the rest would be spread across your second and third years. If you want to take more courses, like me, I'm taking another course in like introduction to machine learning in fourth year. And then you can of course take more software courses if you choose to. But it's not a lot of programming courses compared to like the other like mechanical and your physics and your math that make up most of your degree.
All right, thank you. So next one is a question for Carice, and then maybe if others have thoughts on this general topic. Do you need to have kind of like experience working with physical mechanical devices if you want to pursue mechanical engineering? Would it be necessary to have the experience? I'll just mention from an admissions perspective, you don't necessarily need to have engineering related experience as part of our admissions process. We really look for evidence of transferable skills on our admissions information form and things like that. But just generally, I guess, in terms of like succeeding in the program and going into the program, do you need a lot of experience? What are your thoughts, Chris?
Yeah, I would say it's definitely not necessary to have experience going into the program. I personally didn't really have a lot of experience either. First year when we had the design projects was when I got to learn how to use all those big tools and stuff, and I thought that's cool. So there was that aspect. And after you kind of do like learn how to use those tools, you can just go into the shop and do things on your own. And that definitely enhances your schooling experience, I would say, especially if you want to do like a little bit more manufacturing side. And besides that, first year teaches you how to use the equipment. So you're not like going in there expected to know anything about any of the equipment or have those kinds of experiences. Definitely helps though, because some people that I know that like build rockets like before coming to engineering and all those stuff in my class, like they already know some of like the physics that goes behind it and stuff. So when we discuss those kind of aspects in class, it's easier for them. But yeah, you'll learn everything in class.
Absolutely, yeah. And follow-up question for you. Does mechanical and also mechatronics need a lot of chemistry?
Yeah, so for mechanical, in our first year, we do have one chemistry course, and it's a lot of stoic focused. So not like organic chem and any of that stuff. After that, mechanical has something like material science, as I introduced as one of the industries. Material science is more chemistry focused, I would say, but it's not like organic chem and stuff like that. It's just like, oh, your liquids move faster than your solids, your gas move faster. How do like the molecules and stuff interact with each other? Things like that. So it's not really so much as understanding like the chem you learned in high school. You'll definitely go into more aspects, different aspects of it, I would say. Yeah.
Mhm. Thank you. And Mule, I imagine mechatronics is similar, if not even less chemistry.
Yeah, I mean, we take some intro to chemistry courses in first year, but I don't remember. And then like I think that there's another material science course, but I don't really remember more chemistry courses after that. You can choose to take more material science courses later on in fourth year. Like my roommate, he's going to be taking Intro to Composites. It was like a special mechanical engineering topic course next term. So if you want more of that, there's more, but I don't think we have a lot of it to begin with.
Hmm. Definitely sounds like a common theme, I think, across a lot of programs. That it's like if you want more, then you could do more in your upper years, but if you don't, you can do the bare minimum and then never again.
Yeah, it's not a huge part of our curriculum.
Hmm. Crease, something to add.
Yeah. I was just gonna add for chemistry, if you're interested, kind of definitely like in the fourth year, kind of like what Abby said about the welding specialization. I'm interested in that, so I've looked quite into it. It's if you know what like metallurgy and those kind of processes are, like how do you melt steel, what kind of steel to pick, what properties of steel do you need to make a stronger material, things like that. That's kind of what the chemistry focus is, if you're interested.
Thank you. Um, okay. We will answer one more question that came in and then we'll kind of do some wrap up. Has anyone done co-op or have friends or classmates who have done co-op in the automotive industry, automotive company? Curious, most likely, probably with mechanical.
Yeah, so mechanical is definitely heavy in the automotive industry. I know lots of people in my class that have worked at Toyota. We have a lot of people going into Tesla for the next term. I'm going to be going into Linamar, which is also an automotive um, company, industry focused. So there's lots of opportunities for you to do that, as well as there's a lot of car design teams if you're interested to do that, but don't get a co-op within that field.
Absolutely. And I'll say too, like those design teams can be a great way to get experience in if you know like automotive is a field that you're interested in to get some sort of experience to put on your resume and then get a co-op job related to that. Caitlin, I saw that you maybe had something.
Yeah, I guess it depends what aspect of the automotive industry you're interested in, but from a nano perspective, we've had a lot of people go and work at Tesla and work on like developing new batteries. My uncle works at Toyota and he said he's had nano students work kind of on like he's in quality control, but like kind of with like paints and like the chemistry kind of side of things. So I think there is like a place for nano in the automotive industry. It just depends exactly what aspect you're looking for.
Absolutely. Yeah, great point. Others, possibly?
Yeah, I've actually worked 2 terms in the automotive industry. Actually more on the mechanical side as well, but I know there's a lot of people in Chem Eng that also work at Toyota working in paint or in plastics. I also know some people that have gone down, worked for Tesla in kind of the battery development. I've worked in manufacturing and assembly in the press shops, working a lot on that process optimization, kind of trying to cut costs, trying to cut time down. I've also worked in the R&D side in the material sciences and looking at mechanical properties, and different properties for cooling power electronic components, and cooling batteries and all that. So chemical engineering, you can also definitely experience a lot on that side of it.
Very cool. And I think I kind of I'm loving this question because it really goes to show how diverse engineering is. And I mean, I always tell prospective students like employers don't care too much what type of engineering you do. They care that you do engineering, and then beyond that, they'll look at your resume. They want to see what experience you have. So if you are interested in automotive, you can really study a bunch of different engineering disciplines and still kind of end up in similar careers. Okay, we got 1 minute left, so I'd love to just do a round of kind of final thoughts. And I think my main question for this is, what has surprised you the most about your program? Maybe something that you didn't realize before you started in it. What's kind of surprised you the most? And I'll leave that open-ended for whoever would like to get started with that.
I can start us off. I think I was most surprised by how much math that we actually do in chemical engineering. I think I also had the perception on how much chemistry we do, just based off of I enjoyed chemistry in high school and I came in. I knew there was a lot of the problem solving, but I didn't realize how big of a tool math is. Everything we've kind of learned at the beginning, I will give you the advice, it always comes back in a later course. Like anything you think you can push off and you don't need to know, it will always come back in your applications.
Very cool. And I hear that all the time for sure from chemical engineering students that they just like chemistry, and so that's why they went with chemical engineering. Who would like to go next?
I can go next, I guess. Um, so far in like my program, the thing that surprised me most was probably like learning more about the material science side of stuff. I didn't really know that aspect kind of existed when I was joining mechanical engineering. I thought it was just like a lot of machines and designs. So having that aspect of like making the um, item where the steel will go into to get formed and stuff like that was definitely a new process. Besides that, I agree with Megan, everything builds up. So definitely know your stuff from the beginning, even if you don't, or if like, for example, professor skips it because you don't have enough time, the class will agree with like, and the professor who's teaching you that course now will make sure it's reviewed and get everyone up to date, because for us, we just started into doing matrices again and everyone just made a big sigh because that was like back in 1A and none of us remember what it is. So yeah.
Yeah, thank you. Mule, you'd like to go next?
Yeah, I was gonna say like in high school you might like do like put everything on your plate. Like you need, the grades, you need extracurriculars, you might have a part-time job. In university, it's more about like trade-offs because like I think most people joke like extracurriculars, grades, and sleep. Pick two out of the three. It's very hard to balance everything. Like you want 100%, and you also want all the extracurriculars and clubs, and then you also want to do 10 hours of sleep. Like it's more about trade-offs. I mean, even in engineering, like most of the engineering design decisions, it's trade-offs, right? So you can't have everything. So you got to figure out what's important. And I think that's one of the like thing that surprised me because like I mean in university it's like or in high school it's like you're expected to do a lot, but in university you have more choice. You can pick and choose what to focus on.
Yeah, that's great advice. I think there's a lot of students who choose to study engineering who are perfectionists and want to do everything perfect and 100% at all. But that's not going to be realistic. So, and I've heard a student who always talked about like, unless you wanted to go to grad school after your undergrad, your grades aren't actually that important. The employers care more about your experience. So as long as you're not flunking your classes, your future employers really aren't going to care whether you get like a 98% in your class or 78%. They're going to care about what your co-op experiences are, your design team, stuff like that. Between Amelia or Caitlin?
Okay, I'll take it away.
Sure.
Just like how niche you get into your program. Like, of course, I knew that I was starting biomedical engineering from day one as opposed to general first year, but like you just get so in depth. Like I still have a full year to go and I'm like, how much more like specific can I get? And just like how much more can I learn in my field in only my undergrad? I feel like a lot of other schools you would get to this knowledge and maybe like a grad program. And it's just so impressive that we get there in undergrad because we start off so specialized.
That's a really excellent point.
Okay, and then I would say for nano, like I knew some, like I was interested in some of the applications of nano going into it, but I didn't realize how broad it really is and how many different ways you can like apply it. This is pretty much anything. Um, and then also at the same time, coming into like Waterloo Engineering, I feel like you think of it of such like a big school and like there's so many kids and like it's such a big program. But when you get there, I feel like it feels a lot smaller. Like I feel like your classes, your cohorts are really close and like your professors recognize your face and like they see you in the hallway and you'll have a conversation and like you get really close with your classmates through, struggles in class and just getting to know everyone. And the further you get, sometimes the smaller your classes will get as you kind of go into those specializations. And so it feels like a really big but small community. And I really enjoyed that, and I wasn't expecting it.
Yeah, that's excellent. All right. Thank you so much to all of our panelists for sharing their experiences tonight. Thank you for everyone who has attended or might be watching this recording afterwards. Like I said, I encourage you to continue to reach out through Ask a Warrior with our current students and ginfo@uwaterloo.ca with our admissions team, and just continue asking questions. So thank you all so much and have a great rest of your nights. Bye.